Hello students, today we will discuss about the effect of heat. In our previous discussion, we have discussed that heat is a kind of energy. So whenever we supply certain amount of energy, some conclusions or some effect will be there. So this heat, mostly it has three important effects. So this heat energy, it has three important effects. Number one effect is increase or decrease of temperature. So if one object is heated, its temperature may be increased, or if some heat is extracted from the object, its temperature is decreased, so that we can feel the excess amount of heat on the object. So we can feel or we can sense that quantity or amount of heat. So this type of heat is called sensible heat. So that sensible heat, it results either increase in temperature or decrease in temperature, and the amount of heat or the quantity of heat supplied to any object is equal to m into s into delta T, where m is the mass of the object, s is the specific heat of the object which depends on the material of the object, and delta T is the difference of temperature between the two objects. So when we keep contact in two objects, hot object and cold object, the hot object will reject heat and the cold object will accept heat. So that amount of heat, that quantity of heat, that amount of heat which is rejected by the hot object will always equal to the heat accepted by the cold object. And that quantity or amount of heat is H is equal to m into S into delta T, where m is the mass of the object, S is the specific heat of the object, and delta T is the temperature difference between the hot object and the cold object. So this S is called the specific heat of the object, which defines as S is equal to H by m into delta T. That means S is nothing but the quantity of heat required to increase the temperature of 1 gram of object to 1 degree Celsius. So we have stated that specific heat. So specific heat is the amount or quantity of heat required to increase the temperature of 1 degree Celsius of 1 gram of object. Another term which is very important is heat capacity. So what is heat capacity? Heat capacity is the mass into specific heat. That is called heat capacity of the object. That means how much amount of heat can be capable to hold of certain amount of object. Another term is water equivalent. So what is water equivalent? Water equivalent is the quantity of water. Water equivalent is the quantity of water. How much quantity of water? That much quantity of water, so that to increase the temperature to 1 degree Celsius of certain object. So we can derive or we can define water equivalent as that much quantity of heat required to increase the temperature of 1 gram of water to 1 degree Celsius, and that quantity of heat can give rise to the temperature of certain object to 1 degree Celsius. So this is your sensible heat. That means we can sense the quantity of heat by the change in temperature. Another type of heat is your latent heat. That means here there is no change in temperature. Only it results change of state, solid to liquid, liquid to solid, liquid to gas, gas to solid. We have three kinds of state of any material: solid, liquid and gas, and the interconversion of the change of state, we need certain amount of heat. So that much amount of heat is called latent heat. And keep always remember that in case of latent heat, there is no change in temperature. So quantity of latent heat is equal to mass into latent heat for unit mass. Like latent heat of melting of ice is 80 calorie per gram. That means to melt ice from solid to liquid, in per gram of ice we require 80 calorie of heat. So if you consider the change of state here, if you consider the change of state, and we have plotted the graphical representation of the change of state. Suppose we have minus 10 degree Celsius ice. So first, if we give certain amount of heat, the temperature will be rise to 0 degree Celsius. Then 0 degree Celsius here, this 0 degree Celsius is ice. The temperature of the ice is 0 degree Celsius. Then we will give some latent heat so that all the ice melts, temperature remain constant. All the ice melts into water. Then again, the temperature of the water started rising up to 100 degree Celsius. Then here it is water, and latent heat will provide it into vapor or convert it into vapor, and after that the temperature of the vapor will be rising. So that one is called superheated steam. So this is your latent heat or change of state. We need certain amount of heat, that is called latent heat. And this is number one. Third kind of effect, third effect of heat is very important, which gives rise to certain quantity of expansion of the object. We have three kinds of object: solid, liquid and gas. So in case of solid, we have three physical quantities. One is length, one is area and another is volume. So if we apply certain quantity of heat in a solid of length L1, then what will happen? The length will be increased to L2. So that increase in length is called linear expansion of solid. That linear expansion of solid, what is the relationship between L2 and L1? That is L2 is equal to L1 into 1 plus alpha T, where alpha is called the coefficient of linear expansion. Number B is change of area or expansion of area. If the length increases, then also its area changes, because area is equal to length into breadth. So area, change of area A2 will be initial area A1 into 1 plus beta T. So what is beta? Beta is the coefficient of superficial expansion. That area expansion is called superficial expansion. And last one is the volumetric expansion. So what is volumetric expansion? Volumetric expansion, final volume will be initial volume into 1 plus gamma T. What is gamma? Gamma is called coefficient of volumetric expansion. And this is the relationship between alpha, beta and gamma. Alpha is equal to beta by 2 is equal to gamma by 3. Now in case of liquid, in case of solid term, in case of liquid, we know that there is no length or area. Liquid and gas only contains volume. So in case of liquid and gas, only volumetric expansions will be there. So in case of liquid or gas, we need to take that amount of liquid in certain container. So take that amount of liquid in certain container, the expansion of the container as well as the expansion of liquid will be considered. So in case of liquid, there are two kinds of expansion coefficients. One is real expansion and another is apparent expansion, and the relationship between real and apparent expansion is given as real expansion is equal to apparent expansion plus expansion of the container. Now in case of liquid and in case of gas, so final volume will be V1 into 1 plus gamma T. Now if the volume changes, volume increases, that means the density decreases, because density and volume are inversely proportional. Increase of density results decrease in volume, or increase in volume results decrease in density. If the initial density of a object is ρ1 and final is ρ2, so this is the relationship between the ρ1 and ρ2. So final density will become initial density into 1 minus gamma T. See, their minus sign indicates the density will fall. But in case of water, in certain region from 0 to 4 degrees Celsius, in this region the expansion will not take place. Here from 0 to 4 degrees Celsius, in case of water, if we apply heat, its volume decreases, and finally at 4 degrees Celsius volume will become minimum, so that at 4 degrees Celsius its density of water is maximum, it is 1 gram per cc. Okay, so this kind of expansion, this kind of exceptional expansion of water is called anomalous expansion of water. So if you rise temperature from 0 degrees Celsius to 4 degrees Celsius, the volume of water will be decreased, so that the density of water will be increased, and after that the volume increases, so that density falls. This kind of exceptional case of expansion of water is termed as anomalous expansion of water. So these are the three consequences or three effects of heat. Number one is increase decrease in temperature, which is called sensible heat, because we can make sense of that kind of temperature. Number two is change of state. In this case, the temperature remain constant, so that we can't feel the change of temperature. And number three is the expansion of solid, liquid and gas.